Hello friends, welcome to another mechanical engineering license exam reviewer. Today's topic is mechanics and it's about tension on rope. So we have a problem here. If you have a problem, we have a solution. Yeah. So problem says a rope is stretched between two rigid walls 40 feet apart. At the midpoint, a load of 100 pounds was placed that caused it to sag 5 feet. Compute the approximate tension in the rope. So we analyze our given 40 feet between walls, 100 pounds load at midpoint, and 5-foot sag. The unknown is the tension in the rope. Okay. Now before we go to the solution, I'd like to invite you to subscribe to my channel. Subscribe, like, and share. It takes seconds for you. However, I will greatly appreciate it because it shows your support to my channel. And so, thank you. And here we're back with the solution. So I'm gonna solve this with two solutions. First solution is solving for the angle and using trigonometric functions. Second solution is by similar triangles. So going ahead with solution 1, we let T equals tension that we're looking for. R is the angle between rope and the wall. Also, we need to do some analysis here that the vertical force on each rope is 50 pounds. So the load is 100 pounds and we divide that by 2. That's the vertical force on each rope. And so we find the hypotenuse first. We have our A, 5 feet, that's the sag. B is 20 feet, that's the midpoint of the two walls. And C is hypotenuse. Now C, hypotenuse, is where the tension is that we are solving. So using Pythagorean theorem, we find C is the square root of 5 squared plus 20 squared. C is the square root of 25 plus 400. C is the square root of 425, and we find C as 20.6 feet. Now that we know the hypotenuse, we need to find angle R. Now remembering that angle R is the angle between the rope and the wall. So we use tangent for this one because we are given the opposite uh, side, which is 5 feet, the 5 feet sag, and 20 the adjacent side, which is the midpoint of the two walls. So tangent R is equal to 5 divided by 20. So we solve using our calculators. We find the tangent R is equal to 0.25, and so we find the R, angle R, to be 14 degrees. So finally we solve for T and using sine this time. Why are we using sine? It's because we are given the angle between the wall and the rope, and we are looking for the hypotenuse, in which is the where sorry we are looking for T, and T is located on the hypotenuse side. So we solve for T. We find sine 14 degrees is equal to opposite, which is 50 pounds, divided by hypotenuse. T is the tension, and T now therefore is 50 divided by sine 14. T is equal to 50 divided by 0.2419. We find T is 206 pounds. A little bit longer solution. So some people may find solution 2 to be shorter, easier, and simpler. Solution 2 is by using similar triangles. So similar triangles, we need to make sure that we are using the appropriate side by way of ratio. So by similar triangles, we're finding the ratio. So we are using the opposite side as a ratio to the hypotenuse. So our opposite side is 50. That's the 50 pounds divided by the tension, and the corresponding length is equal to 5 feet divided by the hypotenuse that we already calculated. So 50 pounds is to T, the unknown tension, is equal to 0.2427. Rearranging the equation, now we find T is equal to 50 divided by 0.2427. We find T is equal to 206 pounds. Now the key takeaway for similar triangles is you have to ensure that you're using the ratio of their corresponding side. So if you're using the shortest side of the triangle as a ratio to the hypotenuse, then you must also use the shortest side on the other triangle as a ratio to the hypotenuse of the other triangle. Okay, I hope you find the solution to be helpful, and if you like the video, please remember to subscribe and like and share. And if you have comments, please leave them in the comments section. Alrighty, cheers and have a good one. See you on the next problem and solution.